Welcome to The Explainer. Today, we're pulling back the curtain on the oil and gas refining sector to see exactly how it measures its truly massive greenhouse gas footprint. We're going to be using the SASB standards as our guide for this. If you've ever driven past a sprawling refinery, with the towering smokestacks and that endless maze of pipes, and wondered how anyone actually calculates the sheer scale of the environmental impact going on there, well, you're in the right place. We're going to break down the specific rules that hold these operations accountable for their carbon dioxide, their methane, and everything in between. Here is our roadmap for today. We'll start with the SASB accountability framework, define Scope 1 emissions, look at combustion and flaring, then process, venting, and leaks, and finally wrap up with emission reduction strategies. All right, let's jump right into part 1, the SASB accountability framework and standardizing the sector. To really get this, we have to understand the foundation of how these emissions are reported to investors and the public. You know the old saying, you can't manage what you don't measure, right? For a long time, comparing the environmental impact of one refinery to another was incredibly difficult. It was literally like comparing apples to oranges. And that is exactly where the SASB framework comes in. Now operating under the guidance of the ISSB, the SASB framework sets strict, standardized disclosure topics tailored entirely for the refining and marketing sector. It's a highly targeted framework, focusing heavily on the unique environmental realities of processing petroleum. Look, refining is just an unbelievably energy-intensive process. Energy costs and the greenhouse gas outputs that come with them are a massive share of a refinery's operating reality. The crucial point here is that companies that can cost-effectively reduce their direct greenhouse gas emissions, and we're primarily talking about carbon dioxide and methane here, don't just help the environment. They capture serious operational efficiencies. There is a very real direct link between their environmental impact and the bottom line. Moving right along to Section 2, defining Scope 1 emissions. What exactly are we measuring here? We hear the term Scope 1 thrown around a lot in sustainability reports these days, but what does that actually mean on the ground at a refinery? Well, the standards strictly define Scope 1 emissions as the direct greenhouse gases released from stationary or mobile sources controlled by the entity. Essentially, refineries have to account for the emissions coming directly from their own physical equipment. We're talking chemical plants, storage tanks, fixed-site drilling rigs, and even their mobile truck fleets. The rule of thumb is, if they control the source, they own the emissions. And all of it has to be calculated using the rigorous greenhouse gas protocol. And hey, Scope 1 doesn't just mean carbon dioxide. The SASB standards require companies to disclose gross global emissions across all 7 of the specific greenhouse gases covered under the Kyoto Protocol. Now, sure, refineries are mostly pumping out carbon dioxide and methane, but they still have to meticulously track and consolidate every single one of these gases. That includes accounting for highly complex industrial compounds like sulfur hexafluoride and nitrogen trifluoride. It really goes to show the true depth of what's actually being monitored out there. But here's a tricky question. How do you actually compare a ton of methane to a ton of carbon dioxide? It's kind of like trying to compare different global currencies, right? You need to convert them to US dollars to really grasp their relative value. Well, refineries do the same thing. They use scientific models to translate all these different gases into a single currency, a carbon dioxide equivalent. They use a 100-year time horizon global warming potential, heavily relying on models from the Intergovernmental Panel on Climate Change. This completely standardizes the data, so everyone looking at the numbers is speaking the exact same language. Okay, so the accounting rules are firmly established. But we have to ask ourselves, where are these gases physically escaping from inside the fences of these massive industrial complexes? That brings us to Section 3, combustion and flaring sources. Let's look at the physical reality. First up is the intentional burning of fossil fuels that literally keeps the lights on and the fluids moving. To refine oil, you have to heat it, pressurize it, and pump it. Because of that, stationary fossil fuel combustion for energy supply is, by far, the primary source of a refinery's direct greenhouse gas emissions. Simply generating the power on-site to run the facility produces the vast majority of their carbon dioxide and methane output. Ultimately, they are burning fuel just to make fuel. And this vividly illustrates the sheer scale of the industrial machinery involved. We're talking about massive stationary devices here. Towering heaters and furnaces, giant turbines, incinerators and thermal oxidizers. All of these units are constantly combusting fossil fuels just to maintain normal, everyday operations. Under the SASB standards, every single ounce of gas emitting from these distinct sources has to be quantified, no exceptions. But combustion isn't just for power generation. If you've ever looked at a refinery, you've definitely seen the huge flames burning at the very top of those towers. Those are flared hydrocarbons. During the refining process, you get pressure buildups, off-spec product flows, or sudden shutdowns that result in unrecoverable natural gas. To prevent catastrophic pressure failures, refineries use flaring to safely burn off this gas. So, whether it's during routine operations or sudden emergencies, flaring represents another massive, targeted source of combustion emissions that absolutely must be rigorously tracked. Which leads us to Section 4, process venting and leaks. What about the non-combustion pathways? Seriously, what about the stuff that escapes without being burned at all? It is incredibly important here to distinguish between vented emissions and fugitive emissions. Vented emissions are intentional. They're actually designed right into the engineering of the plant. Think of gas depressurizing during routine maintenance or standard pressure relief valves on storage tanks. Fugitive emissions, on the other hand, are totally unintentional. These are the tiny accidental leaks from a loose flange, a faulty connector, or a worn-out pump seal. The crucial takeaway is that fugitive emissions can be actively tracked down and fixed by the company to achieve near-zero emissions in that specific category. Then there's process emissions. And honestly, the chemistry here is genuinely fascinating. The actual molecular transformation of the oil inherently releases greenhouse gases as a byproduct. When you break apart the molecular structure of crude oil in a massive fluid catalytic cracking unit, or when you process natural gas in an immune unit or a hydrogen plant, those chemical reactions naturally release CO2 and other gases. And they do it without any combustion taking place at all. It's just an unavoidable chemical reality of the refining process itself. All right, final part, Section 5, emission reduction strategies. How do we actually manage all this? Now that we've physically mapped where these massive emissions are coming from, everything from the giant furnaces down to the leaky valves, how do companies plan for the future? Because simply reporting the total tons of gas emitted just isn't enough anymore. Under SASB, companies must publicly disclose their short and long-term plans to manage Scope 1 emissions using a highly structured pathway. They have to establish a base year to be evaluated against, define an exact target year for completion, and most importantly, outline the specific mechanisms like enhanced leak detection programs or new carbon capture technologies that will physically achieve that reduction. And when they set these targets, they have to be crystal clear. Are they aiming for an absolute target or an intensity-based target? This is a vital distinction. An absolute target means a real, fixed reduction in total emissions, regardless of how much the company grows. An intensity-based target, however, means emissions are reduced relative to an operational metric, like greenhouse gases emitted per barrel of oil refined. Think about that for a second. With an intensity target, a company's total overall emissions could theoretically still rise if their production output spikes. They also have to disclose if these targets apply globally or just locally. It gives investors and regulators a perfectly transparent look at their true environmental commitment. Ultimately, standardized measurement really is the critical first step. By forcing companies to rigidly quantify everything, from the towering flare and the massive catalytic cracking unit, all the way down to a tiny invisible fugitive leak in a single valve, the SASB standards create a foundation where actual, measurable climate progress becomes possible. So the next time you see a refinery on the horizon, don't just look at the smoke. Ask yourself, in the race against a changing climate, are these massive industrial giants moving fast enough from simply measuring their impact to actually eliminating it? Thanks for joining me on this explainer, and keep learning.